Good afternoon, class. For this presentation, we will cover chapters 7 and 8 on the redundancy and coherence principles. The following are the objectives for chapter 7. Here are the two key components of the redundancy principle. We will now take a look at how these principles can be applied to multimedia design. The redundancy principle states that when designing multimedia instruction, visuals should be explained with words in audio or text, but not both. Generally, do not add printed text to a narrated graphic. If on-screen text is presented at the same time as on-screen graphics and narration, learners might pay so much attention to the printed words that they pay less attention to the accompanying graphics. But what about the belief that we have different learning styles? A visual learner prefers graphics, illustrations, and pictures. Auditory learners prefer sounds, music, narrations. Therefore, it would make sense that the words should always be presented in both spoken and printed form. This learning style hypothesis is based on the information acquisition theory. 3 ways of delivering information is better than 2, especially if one of the routes does not work well for some learners. Therefore, redundant on-screen text should be included. This theory implies the mind is an empty vessel and people learn by adding information to their memory. However, there is no evidence showing visualizers learn better with visual forms of instruction and verbalizers learn better with verbal modes of instruction. To quote Mayer and Clark, the contrast between the enormous popularity of the learning styles approach within education and the lack of credible evidence for its utility is, in our opinion, striking and disturbing. In contrast, the cognitive theory of multimedia learning is based on the assumption that all people have separate channels for processing verbal and pictorial material. Each channel is limited in the amount of processing that can take place at one time, and learners actively attempt to build pictorial and verbal models from the presented material to build connections between them. These assumptions are consistent with theory and research. One study involves a multimedia lesson on lightning. The non-redundant group viewed an animation and listened to a concurrent narration explaining the formation of lightning. The redundant group received the same narration presentation, but with concurrent redundant on-screen text added. In a series of 8 experimental comparisons, the non-redundant group produced more solutions on a problem-solving transfer test than the redundant group. A study was performed in which researchers presented an 11-minute online slide presentation on human memory. The non-redundant group's presentation consisted of illustrations with the auditory explanation, and the redundant group presentation included the same lesson, either with on-screen text that was presented either sentence by sentence sequentially along with the narration, or all at once on each slide. The lesson was fast-paced and under system control. On a subsequent transfer test, the non-redundant group performed better than the redundant group. Several other studies showed consistent evidence of non-redundant groups performing higher on transfer tests. These other studies varied in topics to include electrical engineering, power machinery for cutting, educational computer games, and the mechanics of plant growth. So, are there any special situations in which e-learning courses would be improved by adding redundant on-screen text? Post your response on the discussion board. According to the authors, there are special situations that will not overload the learner's visual information processing system. First, in the first example, consider using on-screen text and narration when no graphics are included. Information enters through the ears and the eyes, but without the graphics, the visual channel does not become overloaded. Secondly, if the lesson is presented at a slow pace and under learner control. Concurrent narration, on-screen text, and static graphics would less likely cause cognitive overload because the learner has time to process all the material. Printing unfamiliar technical terms on the screen may actually reduce cognitive processing because the learner does not have to grapple with decoding spoken words. A few keywords printed next to the corresponding part of a graphic can aid cognitive processing by directing the learner's attention. This is a technique called signaling. The final exception for when to use on-screen redundant text is when the learner is likely to have difficulty processing spoken words, like students who are not native speakers of the language of instruction. So, what don't we know about redundancy? The kinds of learners. How does adding redundant on-screen text to narrated graphics affect non-native speakers or learners with very low prior knowledge? The kinds of material. Would adding redundant on-screen text to a narrated graphic not hurt or even help when the on-screen material is technical terms, equations, or brief headings? The kinds of presentation methods. Does adding redundant on-screen text to a narrated graphic not hurt or even help when the presentation is slow-paced, under learner control, when the narration precedes the on-screen text, or when the learner is given pre-training in names and characteristics of the key concepts? It would be particularly helpful to pinpoint more situations in which some form of redundancy helps learning. Now we'll move on to Coherence Principle. The following are the objectives for Chapter 8. What is the Coherence Principle? The Coherence Principle is a multimedia principle supporting that the instructor avoids adding material that doesn't support the instructional goal. The key idea here is that more material often means less understanding, and it's commonly violated. You want to keep your multimedia limited to what is central and supportive of the instructional goal of your lesson or content. The first violation of the Coherence Principle is extraneous text or words. This can be written or spoken. The instructor should avoid this by using shorter narrations in their e-learning. Try to stick to spoken narration versus written text, as this will also help to implement the modality principle. Why keep narrations short? As an instructional designer, you will want to be mindful to keep narrations concise. This is because working memory capacity is limited, and you will not want to overload your learner. Also, longer narrations mean longer audio files, and those could take longer to load, or not load at all. Slow or no content means no learning is happening. There are lots of excuses used to justify extraneous text. The first is, I need it to add interest to my content. I need to keep my learner's attention. Actually, adding text that is not needed or relevant to the instructional goal distracts from important information and decreases the learning. Another excuse is that it is added to expand on key ideas and explain in more detail. However, studies show too much information detracts from the main idea and decreases learning. A concise summary is the best route. The second violation of the Coherence Principle is extraneous graphics. Adding irrelevant or complex graphics can actually be harmful because it interferes with the learner's attempt to make sense of the presented material. The big debate that most consumers have is with extraneous graphics. They feel that they need to make the imagery to make their material more relevant or eye-catching. This is known as the Arousal Theory. The Arousal Theory is the idea that embedding interesting elements will cause the learner to become more emotionally aroused and will work harder. Basically, that the learner's emotion affects cognition. Dewey argues that the arousal theory contradicts the cognitive theory of multimedia learning in a few ways. First, the learner is trying to make sense of the material. If they're not trying, meaning no effort, adding interesting material will not change or affect the effort. Secondly, if the learner is trying to make sense of the material and is then able to build a mental model and make sense of the material, then the learner experiences enjoyment. So how does extraneous graphics interfere with learning? Distraction, where a graphic takes attention away from relevant material. For example, in the given images, which would be a more effective graphic to incorporate into a lesson about lightning formation, according to the Coherence Principle? Post your answer and reasoning in the discussion board. Disruption, where a graphic prevents connections being made between relevant material because irrelevant material is in the way. For example, if these two images were pictured side by side in a lesson about the water cycle, the rainfall graph would be the disruption. Seduction, where a graphic primes inappropriate existing knowledge, which is then used to organize incoming content. Let's think back to our lightning example. Inserting a photo of Jim Cantori would be a form of seduction. Still not convinced? Research has shown that learners show less transfer of material when there were irrelevant photos or videos included in the lesson. It was found to be especially harmful to students that are low working memory capacity. Besides irrelevant graphics, complex graphics can also be detrimental. Using simpler visuals or visuals with fewer details presented at one time can help students with integration inferences. Can you think of a time when a simpler visual may be a hindrance to the instructional goal? Post your response in the discussion board. Bottom line, graphics should be as relevant and simple as possible, but learning can be improved by using modest levels of emotional design focused on the relevant visuals. For example, using human-like features or enjoyable colors. There is one more aspect of multimedia to consider when talking about coherence: audio. When designing e-learning, avoid background music or environmental sounds. Background sounds overload working memory, so it's very dangerous when cognitive load is heavy. Narration and sounds compete for cognitive resources in the auditory channel. There is still room for research in terms of coherence principle. For example, instructional design techniques are often effective for novice learners, but may not have the same effects for more experienced learners. This is referred to as the expertise reversal effect. Studies have also not been conducted on long-term instruction in authentic learning environments. The important thing to take away is that coherence does not mean keep the instructional materials boring. It means it is a challenge for instructors to create material that is interesting without extraneous material and using emotional design. Emotional design is not to be confused with emotional or cognitive interest. Incorporating emotional interest is the same as seduction. However, cognitive or emotional interest is that the formation of the mental model creates a sense of enjoyment. The final excuse used to justify extraneous text is to add technical depth, that the learner needs more information to get a more holistic understanding of the topic. Adding additional information that does not directly support your instructional goal will only distract the learner from the ability to construct a model or conceptual understanding. The information will lead to misinterpretations and ultimately block the learner from being able to make connections to the relevant information. Thank you, and have a great evening.